So the next few sections have to do with formulas that you are given on the exam. Today we're going to look at what are known as the sum and difference formulas. And they're here at the top of our screen. So these are given on the Regents exam. So sum obviously means add, difference obviously means subtraction. And what we have here are the functions of the sum of two angles. So the sine of an angle plus an angle, the cosine of an angle plus an angle, the tangent of an angle plus an angle. And the formula follows. So if I'm looking for the sine of, let's say, the angle of 30 degrees plus 45 degrees, then I use the formula sine of A, which is angle A, sine of 30 degrees, cosine of B, which is angle B, cosine of 45 degrees, plus cosine of angle A, so cosine of 30 again, and then sine of angle B. So we're really just using the angles, filling them in for the angles A and B. And then we would go and work all of that out. So those are the sum, and here are our difference formulas, difference meaning subtraction, and you can see all the way down we have subtraction. So the goal of today is to get used to writing those formulas down, using them, paying attention. Are they giving us an angle, or are they giving us something that we can fill in right away? So let's start with some easy ones. The first few have us finding the exact value. Now remember, that possibly means that there's square roots in the answer. The exact value of the sine of 75 using 45 degrees plus 30 degrees, because that will give us 75. So since I'm using the sine of two angles added, I need to start by writing that formula down. So the sine of A plus B formula from above says sine A cos B plus cos A sine B. And here we can see that angle A is 45 degrees and angle B is 30 degrees. So I'm going to go through and substitute for A, the 45. So I have sine 45, and substitute for B, a 30 degree. Cos of 30, cosine of angle A, and sine of angle B. There we go. All that's left to do from there then is write down the values that we know these are. Now these are going to be from the chart, so you might want to do a quick little chart on the side, or look back in your chapter 9 notes. You may have memorized them by now. That would be great. The sine of 45 is the square root of 2 over 2. The cosine of 30, square root of 3 over 2, plus, now we're multiplying those, so I can see right away I'm going to get square root of 6 over 4. And over here's cosine of 45. The sine of 30 is 1/2. And I'm multiplying those. So I did those, these. Radical 2 over 4. And I'm adding these. And that gives me the square root of 6 plus the square root of 2 all over 4. Of course, I can't combine the square root of 6 and the square root of 2. That's your final answer. That is the value of the sine of 75. If you really wanted to check, so you want to put your calculator in degree mode and put in the sine of 75 degrees. Hit enter and see what you get. Then try and put in, you might want parentheses if you're going to do it all in one, the square root of 6 plus the square root of 2 divided by 4. Otherwise, do the square root of 6 plus the square root of 2, hit enter, and then divide by 4. So what you got for the sine of 75, of course, should match. Let's try another one of these. Find the exact value of the cosine of 165. All right, 165. Using what? So what can we do with 165 degrees? Well, 45 degrees plus 120 works nicely. 45 degrees is in the chart. And 120 degrees has a reference angle of 60. So I know that that's in the chart as well. We'll just have to be real careful about whether our values are positive or negative. So you want to go back and think about, there's a lot of pieces to put together here. You can certainly take 120 and QRS, whether you're doing the sine or the cosine or the tan. You can just try and remember 120 lands in quadrant 2, and so the sine of 120 will be positive, and the cosine of 120 will be negative. And again, it's based on a reference angle of 60. So we want to do a little pre-planning and anticipate that the 120 will take a little more work. So I'm using cosine of an angle plus an angle. Let's grab that formula. Cosine of A plus B from up above says cosine A times cosine B minus sine A times sine B. Now fill in for the angles, 45 for A, 120 for B. All right, now we'll go through and we'll write down those values. The cosine of 45, square root of 2 over 2. The cosine of 120, remember what's going to be negative. It's based on 60, and the cosine of 60 degrees is 1/2. So it's negative 1/2. Minus the sine of 45, and the sine of 120. Sine of 60, that reference angle, is square root of 3 over 2. And sine in quadrant 2 is positive. So let's multiply now. Radical 2 over 2 times negative 1/2 is negative square root of 2 over 4. And square root of 2 times square root of 3 is square root of 6 over 2 times 2 is 4. And we get negative square root of 2 minus square root of 6 all over 4. Crazy looking answer. And again, you could check by putting cosine of 165 in your calculator, and then put this numerator divided by 4 in your calculator. You should have the same value. Okay, now let's try a tangent value, tangent formula. We've got tangent of 15 degrees using subtraction. So I would say 45 degrees take away 30. That works. Now if 60 degrees minus 45 degrees popped into your head, that works as well. So there's not just one way to do these. I'm going to stick with the 45 minus 30 since I thought of that one first. 45 degrees take away 30 degrees. So we want our tan of A minus B formula from up above. Copy that down. let's substitute in our angles. We are doing the tangent of 45 minus 30. So angle A is 45. Angle B is 30 degrees. So we have the tangent of 45 degrees minus the tangent of 30 degrees all over 1 plus, and down here we're going to multiply the tangent of 45 times the tangent of 30. So these are all values from the chart again. Tangent of 45 is 1. Tangent of 30, we have the square root of 3 over 3. And those values are repeated down here, but as a product. All right, tangent of 45 and tangent of 30. So this gives us, I'll do the product, 1 minus the square root of 3 over 3 over 1 plus the square root of 3 over 3. Now this is a complex fraction. Complex fractions we did very early in the year. You need to remember you have to simplify those. So the way to simplify is to figure out your least common denominator. I've got 3's. LCD is 3. And then multiply each term then by 3. I can get rid of those. They're just going to be in the way. So multiplying this by 3, multiplying this by 3, multiplying this by 3, and multiplying this by 3, then gives us a simplified answer, 3 minus the square root of 3 all over 3 plus the square root of 3. Now officially, we're not supposed to leave radicals in the denominator either. So this would be simplified by multiplying by the conjugate. All sorts of old concepts coming up. So conjugate, 3 minus the square root of 3, 3 minus the square root of 3. It's the conjugate of this denominator. And that gives us, we have to do a lot of foiling here, 9 minus 3 radical 3 minus 3 radical 3 plus 3 all over 9. These drop out, remember, and minus 3. So we end up with 12 minus 6 radical 3 all over 6, which then reduces. It's the never-ending problem. 2 minus the square root of 3. And let's just put that in real quick into your calculator. 2 minus the square root of 3, and then, here we go, 2 minus square root of 3, I'm doing it with you, enter, we get that this is approximately 0.2679, and then remember what we were trying to find the value of, the tangent of 15. So let's go put in the tangent of 15, and indeed we have the same value. So we're happy. All right, let's see what else we have. So those are problems where we're finding the exact values using values that we already know. Number 4 is a little different. Show that cosine of 90 minus theta equals sine. So we're actually, in a way, proving an identity. You can see they're suggesting cosine of A minus B, because we are subtracting 2 angles. So that formula, always write the formula down first. Cos A cos B plus sine A sine B. Then figure out what you're actually finding the value of, cosine of 90 minus theta. So in this situation, the angle A will be replaced or substituted with 90 degrees. The angle B, we will substitute in theta. So let's go all the way through. A is is 90 degrees, B is theta. And then we evaluate the two that were given. Cosine of 90 is 0. So 0 times the cosine of theta, well, we know that's going to be 0. The sine of 90 is 1. And 1 times the sine of theta is the sine of theta. So we end up with the sine of theta, which is exactly what they asked us to show it equals, sine of theta. Let's throw some radians in. So if angle A is pi over 3 and angle B is 3 pi over 4, find the exact value of the sine of A plus B. So sine of A plus B, write the formula. Sine A cos B plus cos A sine B. They're giving us angle A is pi over 3. So we're finding the sine of pi over 3. They're giving us angle B, 3 pi over 4. So we sub in A. Now I know many of you would switch to degrees if you'd like to. That's 60 degrees, and this is 135 degrees. So sine of pi over 3, cosine of 3 pi over 4, and now we evaluate. The sine of pi over 3, the sine of 60, that's from our chart. The cosine of 135, so quadrant 2, reference angle of 45. So these are the 45s. Cosine in quadrant 2 is negative. So it's negative, and the cosine of 45 is radical 2 over 2. So negative radical 2 over 2. Doing those in a little bit different way than we normally do, but we put the negative in there and we get negative. Cos of 135 is negative cos of 45. Cosine of pi over 3 is 1/2. And the sine of 135, QRS it. Quadrant 2, of course, reference angle is 45, of course, and sine is positive in quadrant 2, so the sine of 45 is radical 2 over 2. Just have to watch out for those negative ones. Know what quadrant you're in. So we have negative square root of 6 over 4 plus square root of 2 over 4, and putting them together over 4, negative square root of 6 plus square root of 2. Again, we can't combine those. They are not like. Okay, so now for a twist. Make this a little tougher. Question number 6 says, find the cosine of A plus B if the tangent of A is 4/3 and the sine of B is 5/12 for acute angles A and B. So acute angles, that's great. We know they're both in quadrant 1, so no fancy stuff to worry about, no sign changes. So there's two different things you have to do here. First, always write the formula down for what they're asking you. The cosine of angle B plus angle A, or angle A plus angle B, is the cosine of A times the cosine of B minus the sine of A and the sine of B. So we've seen from our previous examples, when we had 30s and 45s and 60s, when we knew the angles, we filled them in and we knew these values. But we don't know the cosine of A and the cosine of B because we don't know the angles. But we do need these four values. So the other part of the problem is that we need to figure out the cosine of angle A and the sine of angle A and the cosine of angle B and the sine of angle B. So we're going to ask you to draw pictures. If the tangent of A is 4/3 and it's in quadrant 1, then angle A can be represented like this. It's opposite over its adjacent, so katoa. So a 4 on the opposite and a 3 on the adjacent. Quite nice numbers by the Pythagorean theorem. You know that your hypotenuse will be 5. So your hypotenuse is 5. Well, that's great for angle A, because now I can fill in the cosine of A. Once you've done your work, the cosine of A and the sine of A. So the cosine of angle A, adjacent over hypotenuse, is 3/5. That one's filled in. And the sine of angle A is the opposite over the hypotenuse. So that one's filled in. We're going to do the same thing for angle B. We're going to draw a picture. It's also in quadrant 1. It's a different angle. That look a little more straight. There we go. Angle B, we know the opposite is 5 and the hypotenuse is 12. And so 5 squared plus whatever the other side is. We got 25, 144, subtract, that gives us 119. Not pretty numbers, but we can deal with it. So this side is the square root of 119, the adjacent side. Now that we have our whole triangle figured out, we can go and fill in the cosine of angle B and the sine of angle B. Need to draw the pictures, need to know all the parts of the triangle. So the cosine for angle B, adjacent over hypotenuse, and the sine for angle B, opposite over hypotenuse. Whoops, opposite is 5, hypotenuse is 12. There we go. And then multiplying our first two, we have 3 times the square root of 119 over 60, and 4 times 5 over 60, and our final value is 3 times the square root of 119 minus 20 all over 60. And that can be checked just like the others. So I think what we'll do is a couple more here. I don't want it to be too long, but there are all sorts of different questions to do. This one's similar to the one we just did, so let's leave that. Let's do 8 and 9, and then we'll be done. So 8 and 9. 8 is asking us to do the tangent of A plus B. Let's get that formula written down. We need the tangent of A. We need the tangent of B. And their product on the bottom, tan A, tan B, subtracted from 1. So let's see what they give us for our information. The sine of angle A is 0.6. And the tangent of B is 4. Oh good, that one's done. Tangent of B is 4. We'll sub that in a moment. But for the tangent of A, I'm going to need to know I'm going to need a triangle. So, sine of A is 0.6, which I hope you realize is 6 over 10 or 3 over 5. It's nicer to work with fractions. A is in the second quadrant. So when I draw it, I'm going to the second quadrant, just to help you remember signs and whatnot. So the opposite side is 3. The hypotenuse is 5. we just did this Pythagorean triple, the 3, 4, 5 with the 5 on the hypotenuse. So that's all set. So if I look at angle A now, and we know for my formula, we need the tangent of A. The tangent of A is the opposite over the adjacent, and in quadrant 2 it's negative. And of course this 4 directionally is also negative if you do it like that. So tan A will be replaced with negative 3/4. Tan B will be replaced with 4. Then it's just a matter of doing the arithmetic. All right, let me move this. Do the rest of this work. Negative 3/4 plus 4. I'm going to make it into a complex fraction, so we can do another one of those. And this will become addition, and actually 4 and 4 will reduce, so I'm just going to have 3 down there. All right, so I see a 4 in the bottom, so if I multiply every term by 4, it will simplify this. A couple ways to do this. Those reduce out. Negative 3 plus 4 times 4 is 16, all over 4 plus 12. And so I have 13 over 16. 13/16 is that answer. All right, last one I wanted to do with you, and there's lots more to do in class tomorrow, is this question with these arctans. It's just a different way of saying that the tangent of angle A is negative 2/3. Remember, arctan is the inverse of tan. And here the tangent of angle B is positive 2/3. So I'll leave this one for you to finish up. I'm going to recommend first, write the formula for what you are being asked to find. Number 2, substitute in your values. And then you're going to do the work and make sure you have your answer in simplest form. Okay? I'll see you in class tomorrow. We'll do some more problems together. Make sure you write down your questions. There are lots of different ways to approach this topic. Lots of different ways to ask questions. So there could be some that are easy for you and others that you have questions on. See you tomorrow.